find nth derivative of, that was the problem. First problem was find x square e raised to x cos x, right? So do you want me to write the answer or you want me to show it? So suppose first function is x square u into v, okay? So nth derivative, this is f of x, u into v. So our Leibniz says that you do it exactly like binomial theorem, and therefore the answer for this is 2 raised to n minus 1, n minus 2 whole divided by 2 e raised to x inside bracket 2x square cos x plus n pi by 4 plus 2 raised to 3 by 2 into nx into cos cos x plus n minus 1 times pi by 4 plus n into n minus 1 cos x plus n minus 2 times pi by 4 square bracket. Okay, so let me know if some of you want me to do this problem in detail. I can write down the solution, or I think, yeah, I have given you sufficient time to solve it last lecture. You cross check your answer. If it is matching, then let us move and solve the other problem. Basically, why there are three terms, term number 1, term number 2 and term number 3, is because after three terms, the higher derivatives of x square will vanish, will become 0. Therefore, in first term you have x square as it is, in second term you have x, and in third term you don't have x as a multiplier. So those are the three different derivatives of the first function x square. And of course, for this function we have found out nth derivative, where a is equal to 1, b is equal to 1, c is equal to 0. So it is root 2, r is equal to root of a square plus b square, which was equal to root 2. And theta was tan inverse phi, angle phi was tan inverse b by a, which was equal to tan inverse 1, which is equal to pi by 4. Okay, therefore this pi by 4 business is appearing everywhere, because that phi angle is pi by 4. So when you take n minus second derivative of second function, this is n minus 2 times pi by 4. When you take n minus 1th derivative, it is n minus 1 times pi by 4. When you take nth derivative, this. So if you use Leibniz formula, sigma r goes from 0 to n choose r into u n minus r v r. That is what is your derivative of f, nth derivative of function f, which is equal to u0 v0. Okay, question number 2. Cos inverse y by b is equal to log x upon n raised to n. Prove that x y n plus 2 plus 2n plus 1 x y n plus 1 plus 2n square yn is equal to 0. Okay, so take sufficient time to use this as a given identity, prove what is y n plus 2 n plus second derivative of y, n plus first derivative, nth derivative. Try to prove this, and once you are done with proof, you show me that yes, proved. I cannot go through your proof, complete proof. Okay, so if you differentiate the given quantity with respect to x both sides, what will you get? Cos inverse derivative, radical, so check whether this is correct, minus y1, that is first derivative of y, root of b square minus y square, that is the derivative of LHS. Basically it is 1 minus y by b bracket square into, that is minus 1 upon radical 1 minus y by b bracket square, that is cos inverse derivative, into derivative of y by b, that is y1. 1 upon b, y1 makes it minus y1 radical b square minus y square. And what is the derivative of this? Derivative of this after simplification is going to be n upon x. Let me show you how it is. First of all, log of something is 1 upon that quantity, so n upon x raised to n, that is 1 upon x by n raised to n, correct, into derivative of this quantity is n times x by n raised to n minus 1. Okay, that is what is derivative of this quantity, and then derivative of the inside one is 1 upon n. Okay, so if you multiply all these three, because this and this is reciprocals of each other, will leave only n by x, and n gets cancelled, that makes it n by x, which implies x xy1 with negative side is equal to n radical b square minus y square. If you square both sides, you will get x square y1 square is equal to n square into b square minus y square. Correct? Now this is 1, and you see here you have n plus 2. Okay, and the last term is yn. So if we differentiate this one more time, what do we get? LHS and RHS. So if we differentiate with respect to x one more time, we get 2x square, 2 comes here, then y1 into y2 plus derivative of x square 2x into y1 square is equal to n square b square is constant, so n square inside bracket minus 2y y1. Okay, if we rearrange this, we get x square y2 plus x y1 plus n square y is equal to 0. Okay, Now this is what is the required version of the given statement. This is what is the required version of the given statement. Now you apply Leibniz for nth derivative to this term and this term separately, you will get this. Check. Next problem. If, I think it is third problem, if y raised to 1 upon m plus y raised to minus 1 upon m is equal to 2x, then prove that x minus 1, sorry, x square minus 1 into yn plus 2 plus 2n plus 1 times x into yn plus 1 plus n square minus m square yn is equal to 0. Correct. First of all, you should again simplify it. Then maybe solve it, then differentiate it. So, this is 1 upon y raised to 1 upon m. So, from here, what you can write, y raised to 2 upon m minus 2x y raised to 1 upon m plus 1 is equal to 0. So, it is quadratic y raised to 1 upon m. Therefore, y raised to 1 upon m is equal to minus b, that is 2x, plus minus under root 4x square minus 4 upon 2, which is equal to x plus minus radical x square minus 1 is y raised to 1 upon x. Therefore, y is equal to x plus minus radical x square minus 1 bracket raised to m. So, first derivative y1 is equal to m into x plus minus radical x square minus 1 raised to m minus 1 into derivative of this is equal to 1 plus or minus derivative of this is going to be 2x and this is 1 upon root of this, so x upon radical x square minus 1. That is what is the derivative. Okay. After simplifying, squaring both sides, is just a moment. काय करूया आता simplify करूया, which will be equal to m into x plus or minus radical x square minus 1 raised to m minus 1 into plus minus carry करायचे ना, radical x square minus 1 plus minus x upon radical x square minus 1. That is your y1. So, then what will happen after this? I have a direct step written with me. Let me check whether it is correct. Squaring both sides, we get x square minus 1 into I1 square is equal to m square y square. Okay. So now here I can replace this term by y, but there is one term which is less. This is minus 1. So check whether this is correct or not. Let me cross check. Now suppose I write it as y1 is equal to m times. Suppose I make it y, then what will happen? Into y upon x minus, hello, yes, hmm, yes. हो, येतील डिटेल्स ते अशा म्हणजे अजून वेळ आहे थोडा. त्याचा एक डेमो येईल, हाऊ टू गिव्ह एक्झाम, एव्हरीथिंग विल बी एक्सप्लेन्ड. SMS येईल तुम्हाला, त्याच्या लिंक्स येतील सगळ्या, एक डेमो येईल, सगळं होईल. हम्म. येईल ना, 2 दिवस आधी पाठवतो आम्ही ते, कारण बरेच रजिस्ट्रेशन उशिरा होतात ना त्यामुळे. हम्म. हो, ऑनलाईन हो, नाही. ओके, या, थँक्यू, थँक्यू. हां, बरोबर चाललंय का बघा? This is what it is. If I write y here, then I have x plus minus radical x square minus 1 raised to m, and then divided by, I have minus 1. So this goes in the denominator, and but my cancel
So they are the same terms, right? You just put.
They are the same terms, but then plus minus, if it is plus or minus,
Sir,
yes,
y raised to 1 by m minus y raised to minus 1 by m काढलं तर सोपं होईल ना.
where is right?
Y raised to 1 by m minus y raised to minus 1 by m is equal to 2 root x square minus 1.
Acha. Anyway, I mean,
Here, sir.
Here when we have plus for the y is equal to that term, where we have minus for the differential.
But I think, is it correct from this step to this step? Is it correct?
Yes, sir. Because
Yes, sir.
sir, if we take the,
Yes.
because if we take the plus term, then
Yes.
that becomes plus 1. If we take minus term, it becomes minus 1. But in squaring, that minus plus does not matter.
Yes. Anyway, you are anyway squaring it, so minus plus will not matter, and eventually you will get this is equal to this. Okay. Okay. So further we solve from here, and you can spend some time to arrive at this stage from this stage, but it is true. Now differentiating one more time with respect to x, differentiating with respect to x, we get 2 times x square minus 1 into y1 y2 plus 2 x y1 square is equal to 2 m square y1. After simplifying this, you get x square minus 1 into y2, y1 gets cancelled from everywhere, plus xy1 minus m square y is equal to 0. So this is the term, this is the simplification of the given, such that if we apply Leibniz to this, we get the identity that is to be proved. It is more algebra problem than a differential calculus problem. Only thing that whenever you are supposed to take derivative you are supposed to differentiate. Otherwise, it is algebraic simplification problem. So from here to get this is again applying Leibniz to each and every term. Separate, apply Leibniz to this. It will end up having, I think, 3 terms because x square is there. Apply Leibniz to this, it will give you 2 terms. And apply Leibniz to, I mean, you need not have to apply Leibniz to this because this is constant, only 1 term. And if you add them up, you will get this identity. Okay? Let me know if you are not getting. You can write the proof in detail. Question number 4. Y is equal to log x upon x. If y is equal to log x upon x, prove that yn is equal to minus 1 raised to n factorial divided by x raised to n plus 1 inside bracket log x minus 1 minus half minus 1/3 minus dot 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 minus 1 by n. Take your time. Now x raised to minus 1, that is first function. Suppose u0 is equal to x raised to minus 1. What will be u1 minus 1 x raised to minus 2. Right? Which is equal to minus 1 upon x square. What will be u2 minus 1 into minus 2 into x raised to minus 3, which is equal to 1 into 2 into 1 upon x cube. What is u3 minus 1 into minus 2 into minus 3 into x raised to minus 4, which is equal to minus of 1 into 2 into 3 into 1 upon x raised to 4. Dot dot dot. So if it is un, depending upon n is odd or even, you have, when it is odd, you end up getting minus sign. When it is even, you don't end up getting minus sign. Therefore, minus 1 raised to n into, if it is 3, it is 3 into 2 into 1. Therefore, n factorial divided by x raised to n plus 1. That is nth derivative of 1 upon x. So, Leibniz to this, y u0, that is 1 upon x, or maybe let us do it for log x as u0. So log x is u0 into nth derivative of 1 upon x, which is minus 1 raised to n factorial upon x raised to n plus 1, plus n choose 1, that is n, into first derivative of log x, that is 1 upon x, into n minus 1th derivative of 1 upon x, which is minus 1 raised to n minus 1 into n minus 1 factorial divided by x raised to n, plus, now this will continue, n choose 2, n into n minus 1 upon 2 factorial, that is n choose 2, into, this is 0th derivative, this is first derivative of log x. Now we have to differentiate this, which we, I think, have already done it, which is minus 1 upon x square. that is next derivative of this, and n minus 1th derivative of this into minus 1 raised to n minus 2 into n minus 2 factorial upon x raised to n minus 1. बरोबर आहे प्लस हे चालू राहणार. So now is this equal to this? So suppose we take out minus 1 raised to n into n factorial upon x raised to n plus 1 common. Then first term is log x. This n x raised to n plus 1 is taking place everywhere, no issue, correct? Then n minus 1 factorial into n is n factorial minus 1 raised to n minus 1. We have 1 minus. Second term is minus. Here denominator is x raised to n plus 1, correct? N factorial is also matching. Now this is minus 1 also will match, and you will get this minus half. Plus term will be minus 1, which is equal to RHS. Good. Next, question 5. In is equal to nth derivative with respect to x of x raised to n log x. To that, In is equal to n minus 1 plus n minus 1 factorial. This is easy. The hint is you want in minus 1. So when you are taking nth derivative of this quantity, it is as good as taking n minus 1th derivative of this quantity, first derivative of this quantity. So if you look at nth derivative as n minus 1th derivative of first derivative, I think this problem will be solved. Check. So n is equal to derivative n minus 1 upon dx raised to n minus 1 of ddx of x raised to n log x, which is equal to d n minus 1 upon dx raised to n minus 1. What is derivative of this? It is x raised to n upon x plus n x raised to n minus 1 log x. Okay. So now you can actually split them, which is n times dn minus 1 upon dx raised to n minus 1 of x raised to n minus 1 log x plus this is n minus x raised to n minus 1 dn minus 1th derivative of x minus 1 of x raised to n minus 1. So this is equal to n. If you look at this is in minus 1 plus what is n minus x cube. We want to find out derivative of third derivative of x cube. First derivative is 3x square. Second derivative is 3 into 2 into x, and third derivative is 3 into 2 into 1. So n minus 1th derivative of x raised to n minus 1 is n minus 1 factor. That is what we wanted to prove. N into in minus 1 plus n minus 1 factorial. Okay. Sure. Last problem of the day, sixth. Prove that. One plus n square upon 1 square plus n square into n minus 1 square upon 1 square into 2 square plus n square into n minus 1 square into n minus 2 square upon 1 square into 2 square into 3 square plus dot 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 is equal to 2n factorial upon n factorial raised to 2. Can I enjoy? As I said, when I am giving you this problem at this stage, it has something to do with nth derivative. Okay, so you have to observe LHS, observe RHS, finding nth derivative of some quantity in two different ways. One way will give you RHS, another way will give you LHS. Okay, so now I tell you what quantity. You figure out whether LHS is equal to RHS or not. You are supposed to find out nth derivative dn by dx square dx raised to n of x raised to 2n in two different ways. Okay, one directly using reduced skills, which will give you RHS, and second, which is dn of dx raised to n, x raised to n into x raised to n, and applying Leibniz to this, u0, u1. You will get, comparing coefficients, you will get LHS. So that is what is the hint. Spend some time and check whether you get those LHS and RHS in place or not.